For this exercise, we're going to do a coding challenge called Find the Smallest Common Number. And what we're given is 3 arrays. Now the property of all these 3 arrays are that we have only positive integers inside the array, and all the numbers are sorted, right? So this is common amongst all 3 arrays. And what we need to construct is a function. So let's say it's a function that has a narrative of 3. So we are passing 3 arrays. So in this case, A, B, and C. And what we need to return is a common number. So in our case, the common number amongst all 3 of these guys is 10. So we return 10. Yeah. So because this is, we only have positive integers, if we don't find any common numbers inside all 3 arrays, we return -1 in those cases. Let's say that we don't have 10 here, we would return -1. Cool. So how would we solve this? So one way of solving this would be to have 3 pointers that points to index 0 of each array. And what we do is on each stage, until one of those pointers is out of bounds for a particular array, we first, of course, compare all the 3 numbers, and if they're not the same, we advance the pointer that points to the smallest number, right? So in this case, we would just advance 2. It's still the smallest number until we get to 10, and then 10 is no longer the smallest one. So we advance the smallest one, which is the purple one, and we do this until we get to the number. It's not smallest anymore. Right now it's 7, 9, and 10. Okay. Now we see that all the numbers are the same, so we can return 10 in this case. Cool. But let's say if we don't have 10 anymore, let's say that our numbers don't have 10, what we would do is advance the yellow pointer, because yeah, like this. Cool. Now our pointer, which is red, can point to 12. Again, the smallest is 10. Let's advance it. In the next one, in the next iteration, the smallest again is yellow. Let's move the pointer, and now that pointer, a yellow pointer, is out of bounds, we can just terminate the while loop and just return -1, because we haven't found the common smallest number, right? So let's just go to the code editor and see how this would look in code. So we have these 3 arrays. We can print smallest common number, pass all 3 arrays here, and what we expect is to get 10. Cool. We'll initialize pointers. Let's call them A1, B1, and C1, and all of these pointers will point to 0. So while A1 pointer is within bounds of A, and B1 is within bounds of B. Let's do the same for C. We can compare all the numbers, so let's do that. And if they're the same, we can just return the number like this. If not, let's get the smallest number amongst those 3 guys. Like this, and we can compare. So if A1 is equal to smallest, right, we can advance A1 like this, right? And if so B so let's advance, else we can advance C1 like this. If we're out of loop, we didn't find the smallest common number, and we can just return -1 like this. Cool. So let's just quickly check the code. So we have 3 arrays. We are calling the smallest common number function. We pass the 3 arrays. We initialize all 3 pointers. The bounds look good. If all the 3 numbers are the same, we just return the number. If not, just look at the smallest number and advance the smallest pointer, right? So if we run this, we should get 10 back, and we do. If we, let's say, remove 10 from here, we should get -1, and we do. Cool. So let's talk about time space complexity for this one. So it would be, let's say, max A, B, and C for time. So we could have, like, let's say A could be 1000. We could have B would be 1 through 900, and then C would be 1,000,000, right? So we would basically be looping over every element from the array called B, right? So that's why we have maximum number between A and B and C. That's for time. And for space, we can say that we're just initializing 3 variables, which in time space complexity or cyclomatic complexity can be just O of 1. So we have constant space here. Okay, cool. So that's it for this exercise, and I see you guys next time. Bye.